are going to discuss the non-cross-linked polymer and the cross-linked polymer, right? Non-cross-linked polymer is the softened and melt at high temperature and high toughness, right? And it will be in low stiffness. For example, polyethylene and garbage containers, okay? And cross-linked polymer decompose at high temperature and don't melt, okay? And it will be high brittleness and it will be high stiffness, okay? For example, polyester resin for aerospace applications. And thermosetting plastics are widely used in aerospace and automobile engineering to form a laminar structure and made by stacking and bonding thin layers of fiber and polymer until the desired thickness is obtained. Right? The fiber in PMC is the various forms. And the various forms means the discontinuous or continuous or woven as a fabric, and principal fiber matrix is matrix in your FRPs or glass, carbon, and Kelber 49. Okay, and also in it will be in less common fiber include boron, silicon carbide, aluminum oxide, and steel, right? And then the glass is the most common fiber material in today's fabrics. It's used to reinforce plastic dates, and around 1920 glass powder is main composite material. Polymerization is the process of joining monomers into a gain chain-like molecule. The methods of polymerization, we have two types. First one is condensation polymerization, and the second one is addition polymerization. At first we are going to discuss polymerization, right? Addition polymerization, the polyethylene, that the structure is shown here, and then condensation polymerization is epoxy, that structure is shown here. The degree of polymerization equal to number of polymer units in a chain. Next we are going to discuss the thermoset, right? In thermoset, the materials are usually liquid or malleable prior to curing and descend to be melted into their final form. Okay, and it has the property of undergoing a chemical reaction by the action of heat, catalyst, and ultraviolet light, etc. To become a relatively insoluble and infusible substance. Okay, these are the main points to make the thermosetting passes, and easy to develop a well bonded three-dimensional structure upon curing. Once you've hardened or cross-linked, they will be decomposed rather than melt. Okay, and the thermoset materials are generally stronger than thermoplastic materials due to this 3D network of bondings. Okay, and are also better suited to high temperature applications up to the decomposition temperature of the material. So this type of method is very important and very useful to make many products in automobiles. Thermosets are made by the mixing components of which reacts and harden either at room temperature on heating. Okay, the resulting polymer is usually heavily cross-linked. So thermosets are called network polymers, and the cross-link form during the polymerization of the liquid resin and hardener, so the structure is almost always amorphous. And on heating, the cross link prevents true melting or viscous flow, so the polymer cannot be hot, or the further heating just causes into discomposition.